Okay, so our problem is 671. Um, Determine the horizontal and vertical components of force that pins A and C exert on the frame. Now we have a frame structure, as you see. It is pinned at A and C. We have a rod AB. There acts a 500 Newton force in vertical direction downwards, and then we have another rod BC. Now distance from uh, horizontal distance from A to the force is given. It's 0.5 meters, and from this force to the joint B it is 0.4 meters. Also the vertical distance from A and B is 0.9 meters. Um, the rod B, or the distance of B from C, is 1.2 meters in horizon, and the vertical distance is 0.8 meters. Okay, so first thing is to draw the free body diagram of the system. Since the rod AB, we will begin by rod AB. Rod AB is pinned at A, only the translational motion is restricted. Therefore, we have only reaction forces. We don't have any reaction moment because it can easily rotate around A. So we choose two axes. Again, horizontal axis as X and vertical axis as Y. So you can choose a different one, but this is our choice. In fact, we choose counterclockwise direction for the moment as positive. Now we will write the equilibrium equation. As you see, we have four unknowns here. So we have the AX, AY, BY, and BX. So X component of the force at B and Y component of the force at B. And then we have the Y and X component of the force A. We choose their direction arbitrarily. If the direction that we choose is, if we find the value negative, this basically means that the direction of the force is in the opposite direction. Okay, so the first thing is to calculate the moment, writing the equilibrium equations. In fact, what we do is first we take the moment with respect to point A. So it is minus 500 multiplied by 0.5. This is the moment generated by the external load, plus By multiplied by 0.9 because it is in counterclockwise direction, and minus Bx multiplied by 0.9, and this has to be equal to 0. So if we do the calculation from here, we get our first equilibrium condition. It is By minus Bx, that's equal to 277.77. Okay, now we write the moment with respect to point B. This will be our second equilibrium equation. Ax will generate a positive moment, so Ax multiplied by 0.9 minus Ay multiplied by 0.9 plus 500 multiplied by 0.4, and that's equal to 0. From here, we will have our second equilibrium equation, that is Ax minus Ay, that's equal to 222.22. Okay. Now, next thing is to use the equilibrium of forces. In fact, sum of the forces in X and Y direction has to be equal to 0. From here, we can easily say that Ax is equal to minus Bx. This will be our third equation. And Ay plus By is equal to 500. So because we choose By and Ay in positive direction. So this is our fourth equation, and we have four unknowns. In fact, from here, we can solve AY and BY, but let's remain it at the moment. Now let's analyze the forces acting on BC. Now at point B, joint B, two rods are connected with a pin. So this basically means that the forces has to be equal in magnitude but opposite in direction. As a result, Bx will be in negative x direction and By will be in negative y direction at point B. Now we can choose the forces at C, reaction forces at C, at point C arbitrarily. So we choose the Cy in positive direction and Cx in positive x direction as well. Now from the force equilibrium in x direction, we can easily say that Cx is equal to Bx and Cy is equal to By, from some of the forces. Now second thing is the moment equilibrium. We can write the moment with respect to point B. We can choose any point, in fact. So sum of the moments with respect to point B is equal to 0. So from here, Cy multiplied by 1.2 plus Cx multiplied by 0.9 has to be equal to 0. Now this tells us something. Cy is equal to minus 3 over 4 Cx. And from here, we can easily say that By is equal to minus 3 over 4 Bx. Now, this basically means that identical to the truss elements, if there is no external load acting on the member, rods carry the load along its direction. This is what it means. Now, I can, after having all these equilibrium equations, from equation 1, I can obtain the Bx. So Bx is equal to, by substituting this relation, expression between the By and By and Bx, we take it and substitute into equation 1. We obtain minus 7 divided by 4Bx, and that's equal to 277.77. From here, we obtain the Bx as 158.729 newtons. Of course, that's equal to Cx. So that is 158.726 newtons. From here, I can calculate the By. By is equal to minus 3 over 4 multiplied by 158.724. 726, sorry. So this gives us minus 119.0.44 newtons. Of course, that is equal to Cy. Now I find the reaction forces at C. Now we are asked for the forces at A as well. From here, I can easily obtain the forces. Ax is equal to minus Bx. So Ax is equal to minus 158.726. Ay is equal to 500 minus By. So that is 500 plus 119.0.44. This gives us the value of the Ay, that is 619.0.44 newtons. Okay, so this is the end of the solution.